Tori,
Can you do question 4 in chapter 13?
still from the review?
Yeah.
Okay.
But you didn't see. Wait, no. It's a different question 4. It's like up there.
Okay.
That one.
Okay, so like you're just typing this into your calculator to find the zeros in the extrema. So negative 4x to the third.
Wait, can you do
Okay. X to the fourth plus 5x to the third minus 9x squared minus 12x minus 2. And I don't really know what to expect here, so I'm just going to graph this over kind of the standard window. If I have to go back and change things, I can go ahead and do that. So I see 4 x-intercepts, right? I see one here, 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 and here. Those are my 4 zeros. So to find one of those, what I'm going to do is press second and trace and select the 0 command. Now let's say we want to find this one right here. So the first thing it asks me is a left bound, so I'm just going to use my left arrow to move my cursor so that it's on the left side of that x-intercept. So there it was there. I'll press enter. Then it asks for right bound, so I'll move it on the right side. That'll do. A guess wherever you're at is fine. So there's my first 0 is negative 6.154163. Okay with that?
Yeah, I'm going to more stuff on the absolute max.
Okay. So you'd repeat that 4 times. To find the extrema, what we're going to be doing is using the max and min command from that same menu, but really we have to be able to see the max and min. Right here is our local maximum, right? But we can't see what's going on down here with the minimum, so I'm going to extend the y values down. So I don't know, I'm just going to take a stab at negative 50. I don't know if that's going to be enough or not. It was not. So maybe we do like negative 200. That still looks like it's got a long ways to go. That captured it though. So there's 3 extrema. There's this global minimum, this local maximum, and this local minimum. So to find the maxes and mins, I'm going to do second and trace and use the min and max commands. So let's find this one first right here. So I pick the minimum command and it's going to ask me the same left bound, right bound guess stuff. So I'm just going to move it on the left hand side and press enter. Move it to the right hand side and press enter, and then just press enter on a guess. So my global minimum is at negative 4.588258, yada, yada, yada. And then I just repeat that same process for these 2. Is that what you needed? Okay. Jesse?
When you say global minimum, could you also say absolute minimum?
Sure.
Okay.
Ben? Yeah, go ahead.
When it says linear regression model, which one do we use? There's 2 linear regression.
It doesn't matter. One of them says like a plus bx and the other says ax plus b. It doesn't matter.
Okay. And so when you're looking to see if the zeros lie in the interval, if it goes plus minus for the first bound and then all plus
Oh, let's see. I always have to go back and double check what the rule is there. Let me look at the notes here real quick. Ah, there it is. Oh no, that wasn't the part that I was looking for. Where's that part? Is it not in here? It's got to be in here somewhere. I know it was in here. Am I crazy here? That's that part. That's that. That's that. Multiplicities. That's that thing. Okay. This is division stuff. Synthetic divisions. Rational zeros. Okay, that's the spot. All right, we can determine upper and lower boundaries of the real zeros of a polynomial with this test. If f of x is a polynomial with positive leading coefficient, we divide by k using synthetic division. If k is greater than 0 and every number at the bottom line is non-negative, then k is the upper bound. Okay, and if k is negative and every number on the bottom is alternately non-negative and positive, then that's the lower bound. Okay? So, Ben, can you repeat your question for me now that I've refreshed my memory on what the rule was? So the lower bound needs to be alternating signs. And the upper bound has to be all positive. You're welcome. Actually, I should say all non-negative. If you get a 0, that's okay. Yeah. For the upper bounds, yes. You said you had 2 questions, though?
Oh, the linear regression one.
Oh, yeah, we already dealt with that one. Okay. Yep, no problem. Jake?
Can you do C for question 7?
So find all the zeros. Okay, so I would start by just writing down my possible rational zeros, which are going to be the factors of the constant term divided by factors of the leading coefficient. Since the leading coefficient is 1, it's just really the factors of that constant term. So I think those are all of them. 1, 2, 3, 6, 7, 14, 21, and 42. So what I'll do then is I'm going to look at the graph to try to see which one of the numbers from this list would be good ones to start my synthetic division with. And I'm going to graph this over the entire interval here. So negative 42 to positive 42, so the smallest to the biggest. And all I really care about are the x-intercepts, so I'm just going to make my y's, like negative 3 to positive, just enough so I can see the x-axis and what's going on. So let's hit graph. So I see something here that's probably 6-ish. Let me double check to make sure I got that typed in correctly, because I don't want to get going on this and have some boo-boo in here that creates a big problem. Okay. So that looked okay. So I'm going to reset my window since it seems that it's something either like 3, 6, or 7. It's hard to really tell from the window that I had what that was going to be. So I'm going to just resume. So let's just go 0 to 14. It was certainly looked like it was in between there somewhere. And take a second look at this. So 1, 2, 3, 4, 5, 6, 7 is what it looks like. And 7 is on my list, so let's go ahead and do our synthetic division. So 1 times 7 is 7, and then add down gives me negative 4. 7 times negative 4 is negative 28. Add down gives me 6. 7 times 6 is 42. Add down, that gives me 0. So that's one solution, since I got a 0 remainder. To find the other solutions now, if I looked at the graph, I didn't see any other x-intercepts, so that tells me all my other solutions have to be imaginary. So they're going to come out of the quotient from this synthetic division. Remember, the numbers at the bottom of the synthetic division is your remainder, and then the constant, and the x coefficient, and the x squared coefficient. So I'm going to take that quotient from my synthetic division, set it equal to 0, and solve. So to solve this, since I know it has an imaginary solution, I'm going to just use the quadratic formula on it. So 16 minus 24 is negative 8. And the square root of negative 8 is going to be 2i root 2 all over 2. And then you can reduce to just get 2 plus or minus I root 2. So those are your 3 solutions then. Is that okay? Ben?
13.4, you do
what question? Question 6. Okay. So I want a polynomial with real coefficients that meets this criteria. So notice that one of my zeros is imaginary. In order to have real coefficients, I also have to have its conjugate. So that one's also going to need to be on my list. And then I'm going to take these 3 zeros that were given and convert them into factors by just like subtracting the number part from both sides, basically setting them equal to 0. And you could subtract the imaginary parts like individually, but I like to do it as like a whole thing. I think it makes the algebra on the next step a little bit easier, but if you don't like to do that, you don't have to do it that way. So I have these 3 factors. So what I'm going to do is I'm going to multiply each of these 3 equations together, giving me x minus 4 times x minus 2x, or 2 plus 3i, times x minus 2 minus 3i. And 0 times 0 times 0 is still just 0. So what I have is a polynomial that has the 3 zeros that I'm looking for, right? So all I need to do now is FOIL this stuff out. I'm going to FOIL these conjugate parts out first. So x times x is x squared. And I have minus x times 2 minus 3i. And then I have minus x times 2 plus 3i. And then I have plus 2 plus 3i times 2 minus 3i. So if I combine my like terms now and distribute things out, that's going to be negative 2x plus 3i, and this one's going to be negative 2x minus 3i. So I just have minus 4x left over when I distribute that stuff through and combine my like terms. And then this piece here is a difference of 2 squares, so it's really just going to be 2 squared minus 3i squared, or 4 plus 9. So that gives me this. And you can always check to make sure you did that foiling correctly by solving that. You should get the zeros 2 plus 3i and 2 minus 3i. If you really wanted to, you could check it there. And then I'm going to distribute through the other stuff. So I have x cubed minus 4x squared, and then minus another 4x squared, so that's really 8x. And then I have 13x, and 16x is 29x. And then that's minus 52. I think I did all that correctly. And then I still don't have my leading coefficient of 2, right? Yeah, so we just multiply everything through by 2. So no big deal there. I know that when I multiply through by a constant, that's not going to change the zeros. So as long as I have the zeros correct, whatever I'm at the end, I can make the leading coefficient whatever I want it to just by multiplying through by the necessary factor. So you're welcome. Does that feel okay, Ben?
I just have trouble factoring like x minus 2 plus 3i, x minus 2 minus 3i.
Oh yeah, just foiling that stuff out can be kind of a hassle. I like to do it that way that I've done. I think I'd make fewer. The algebra is a little bit easier for me there. But you could do it as like a triple FOIL. It seems like there's more crap to keep at track of. Yeah. You're welcome. Gracie? Of course. Who's next? Caroline.
Yeah. Can you do the last problem?
Sure. All right. This is it, right?
Yeah.
Yep. So I just needed to read the directions here to start. So it says, how many zeros must the function have? Well, that's just the degree, so 4. How many extrema can it have? Well, that's 1 minus the degree, so 3. Because really, if you think about it, if you have like 4 zeros, and they're all real, you'd have to turn 3 times to get to them. But we don't know it has to have 4 zeros, 4 real zeros anyways, so like it might not have to turn 3 times if there's imaginary ones that don't actually show up, right? And then it says, solve the thing, right? Find all the zeros and all that, yada, yada, yada. Okay. So my possible rational zeros for this one are, again, factors of the constant term divided by factors of leading coefficient. So in this case, it just plus or minus 1, 3, and 9. So let's take a look at the graph and see what looks like a good one to start with. Oops. So we have x to the 4th minus 6x to the 3rd plus 10x squared minus 6x plus 9. And we'll go from -9 to +9, and probably don't need it to zoom in on or to change that at all, but we'll see what it looks like. Okay, so the graph, I see x equals 3. But if I look at that graph, notice how it's hitting, where it's hitting the graph and then like bouncing back the same direction it came. That indicates something to me. So because this is a bounce, I know it's going to be, has a multiplicity of an even number. So it could be used 2 times, 4 times, 6 times, etc. So when I do my synthetic division, I'm going to use that number at least twice. I might use it more than twice, but I might not. I don't know that until I actually try to do the synthetic division. So again, just kind of grinding through this. Do you guys remember how to do the synthetic division well? Okay. And even right here, I could stop if I notice that if I look at the polynomial I'm left with after doing that synthetic division, that's something I could factor by grouping and grind it out the rest of the way without having to do any more synthetic divisions. But if you want to keep going, that's probably what most of us would have done. But I wanted to point out when you see like 1, 3, 1, 3 like that, that's something you could factor by grouping if you wanted to stop there, but you don't have to. There are problems, not ones that we would, any ones that we saw or what I would expect you to see, but there are problems where the order that you do the synthetic division might matter, and there's problems where, like, to factor it as far as you can, you have to not do all the synthetic division you can do, because you'll get to a piece that, like, 2 things that can't factor anymore, like 2 trinomials that can't factor anymore, that are multiplied together, but if you did it a certain way that maybe you could have gotten something you could have factored sneakily and then been able to separate them. But that's beyond the scope of what we're doing right here. So we saw that, again, we saw x equals 3, worked 2 times because we got remainder 0. And the polynomial I'm left with is x squared plus 1, which obviously isn't divisible by 3 again. So I'm not even going to bother trying to do another synthetic division on this. I'm just going to set this equal to 0 and solve now. Which, again, to do this, I'm just going to subtract 1 from both sides and then square root both sides to get plus or minus I. So there's my 1. And this we would say is x equals 3 with multiplicity of 2 is our other solution. You're welcome. Did you guys kind of remember doing this from last year? This was stuff you should have done in your Algebra 3-4 class. Hopefully it felt pretty familiar. This was a good time for me to be gone for a while. Or at least it was something that you'd done before. Hopefully felt reasonably confident that you could figure it out again. Maybe some of the little details are different, but hopefully it came back to you, right? A little bit? Okay. Happy to take some more questions if you have more. You can, again, you don't have to be from the review. You can ask homework questions or whatever. Is all fine. You know, I'll answer whatever you guys want to answer or talk about whatever you guys want to talk about. Happy to do it. Whew.
How was your quarantine?
It was kind of hectic. You know, my wife and I were both still trying to do work, and we didn't have any childcare. So our less than 2-year-old isn't like, hey, go do this while I work on the computer for an hour age. So, and my wife was reasonably sick to where, like she had a hard time.
Is she better now?
Yeah, she's fine, but she was just like kind of wiped out and had a hard time doing anything. So I had to, I was doing most of the childcare and then trying to do just enough to kind of like kick the can down the road on my classes. But I appreciate you guys doing a good job of taking care of yourselves here. It was good timing in that it was a topic that hopefully you felt reasonably familiar with, to where like, okay, I can kind of jog my memory on doing this. But well, I got sick before Easter, and I thought it was just a cold because I didn't have any real COVID symptoms. I just didn't feel good for a couple of days, and then I don't know, I got sick on like Wednesday and was better by Sunday. And my daughter was sick a little bit before that, so I think she probably had it. And my wife started getting sick on Friday, or Thursday or Friday, went and got tested negative. So it's like, okay, we just have like a crummy cold. And then she went to work, was there the next week or whatever, and went to work a couple of times and stayed home a couple of times because she just didn't feel very good. And then last week on Tuesday or whatever, like they sent her to medical and they're like, you need to go get another test. And she tested negative on the rapid, but then positive on the PCR one later that day. So by that point, she was kind of through the worst of it and was feeling better, but she was, reasonably sick for 2 weeks. Not like I had to be in bed, but like it just sucks to be not in bed kind of thing. Like I can do stuff, but I just don't have a lot of energy and everything feels kind of hard and yucky. So that's what it was like. That was the deal. So I never tested positive, but I probably had it. Well, I had been half vaccinated also, so I don't even know, like. Yeah, I was halfway through it. I got my second shot on Friday last week. But, like, I think even if having been half vaccinated, I probably would have had the antibodies anyways. So, like, I don't know. Like, what's it going to show? I don't know that there's any way to tell it at this point anymore, whether I had it or not. I assume I probably did, just because of the timeline of everything, but. So yeah, that was my quarantine story. It's a good one, huh? I know. You guys all saw the test date on Power School. We're gonna do it on. You guys are gonna be Friday this week. Does that feel okay? Realistic, anyways, like not absurd. I wanted to get one more. Make sure I try to get one more test in for the seniors in case anybody's at a borderline that's like, hey, I need to do well on something to try to pull my grade some way or another. So that's the impetus for trying to squeeze it in this week to give me time to make sure I have that, I can sort out those grades or whatever before they're due next week. Because you guys are done on what, Tuesday next week or something? May 4th? Yeah, there's exam day still. But that, like, I need to know grade-wise, like, do I have to make an exam? Because I only have, like, 5 seniors or 4 seniors or something. So I think I have 3 in this class and then Bobby's in the other class. So I'll get your guys' stuff sorted out here this week. And then we'll figure out what we have to do next week or whatever. You know what I mean? So if you have late stuff that you're on to try to get in still, like, let's try to get that in this week, my seniors, so I have a chance to to get things updated. I'm not scrambling at the last minute. Anyways, yeah, Jacob.
For the test, it wasn't on the review, but it was on the chapter 13 problems. Do you think we're gonna have to do one like number 15? Where it's like just take a story time?
Sure. Yeah, if it made it into the problems, it could be fair game. This was one I think that I put in the, somebody asked about, and we put in the discussion, right? So this is like a general kind of optimization problem. It would be, if there was one on the test, it would be pretty similar in structure to this kind of problem, where it'd be like a volume of a shape based situation. So like it would be very similar, if that helps at all, in terms of what you have to do preparation wise. Okay. What else do you guys want to talk about? We have till 8:50, so you still have a half an hour or so if you got more stuff that you want to talk about or things you want to go over in general. I'm happy to spend some or all of that time doing stuff. Abby?
Can you give another example of the factory where it was like 1 plus like 2i or something like that, because like still have trouble with the factory?
Okay, so when you mean multiplying something like that.
Yeah.
Sure. Number C on the review. I knew what you meant. Okay. So I'm going to skip through a little bit of the explanation and just look at the multiplication part. Is that okay with you guys? So that's what I'm going to be multiplying out, right? Everybody's okay with how I got to there. I skipped over some steps to write that, but it's the exact same work as I did for the previous problem, just with different numbers, right? So the easiest way to do this is to multiply these conjugate pair parts together first. So if I multiply through, I have x times x, which is just x squared. And then x times negative quantity 1 plus I. So I'm just going to literally write it as like negative x times 1 plus I. And then doing the same thing here. So again, negative x and then 1 minus I. And when I do these ones, it's going to be negative times negative, so it's going to be positive. 1 minus I times 1 plus I. Does that feel okay? So again, all I did was FOIL there. I just treated the things in parentheses as like an object in my foiling, right? So then let's just distribute through here. So that's negative x, and then minus I times x, and then negative x, and then positive ix. And then this piece here is a difference of two squares, right? Like a minus b times a plus b. So it's just going to be 1 squared minus I squared in this case. So far, so good. Those guys cancel out because I have a negative ix and a positive ix. And then negative x and negative x is negative 2x. 1 squared is 1, and I squared is negative 1. So 1 minus a negative 1 is 2. So there's the worst part done. Then I just need to distribute this stuff through. So we'll just do like a triple FOIL. And when I combine my like terms here, I have an x cubed, 2x squared, negative 6x, and an 8. Does that feel better, Abby?
Yeah, and if there's not, like if it's like 1 minus square root something, like you won't have to use conjugate, right?
Depends on what the directions say. So in this one, since it says real number coefficients, you don't have to worry about the conjugate. If this was, say, rational coefficients, then yes, you would need the conjugate for radicals also. So it depends a little on the directions there. So having the square root as a coefficient, that's still a real numbered coefficient, so there's nothing wrong with not including the conjugate. But if it said rational, then radical in your coefficient is bad. You know what I mean? Ben? Chapter 13, homework number 50. Okay. This is one that I would just do this just by using factoring methods. I wouldn't do any synthetic divisions. You wouldn't be wrong to do that. But what I notice here is that this is 3 terms, right? And I notice the degree of the first term is twice the degree of the second term. And then I have a constant. What that really looks like is a quadratic to me. Now, it's not exactly quadratic, but it's like in the quadratic form. So if I say let y equal x squared, what I really have then is y squared plus 12y minus 64, which is exactly quadratic. And I noticed then that I could solve this quadratic either by factoring or the quadratic formula. This one factors, right? 2 things that multiply to give me negative 64, and add to give me 12 would be positive 16 and negative 4. So that's what I would do. And then I can substitute back in my x squared. So the x squared plus 16 can't factor anymore because that's a sum of squares. Can't factor sum of squares. But the x squared minus 4 can. And then if I set that equal to 0, I get 2, negative 2, and then plus or minus 4i. And that's the way that I would approach that problem, is I wouldn't do any of the solving techniques that we had talked about, because I think that's way faster and easier. But you could certainly have done it the same way that we had been talking about. When you graphed it, you would have seen zeros at 2 and negative 2. Those would have been the things that you use your synthetic division with. You synthetically divide each of them, and you're left with 1, 0, and 16 at the bottom, which is the x squared plus 16. It'll work out the same way. But I like doing that because I don't have to graph it on my calculator, right? I don't have to make a list of possible rational zeros. I don't have to do any of that stuff. I just factored it, Yeah, no problem. Just to be clear, you could have still done it the way you did the other problems in this section. It wouldn't be wrong, right? I don't even know that it would have been that much longer. I don't think it would have been that much more space on your paper. I just think it's a little bit quicker because I didn't have to go to the calculator to do anything. This is all stuff I just kind of did in my head and had to write down a little bit of notes on or whatever. But you're welcome to do it either way. It's no big deal. I just wanted to point out that this one there was particularly had a nice shortcut involved with it, or a nice alternative way to do it, as opposed to the other ones where there's no obvious factoring shortcut. Well, I take that back. 48, you could have factored that by grouping and not had to do anything there either. You wouldn't have to do any division on 48. You could have factored that by grouping. But those are the only ones. The other ones are not very nice, and you would have to do the long divisions for. I mean, there's ways to factor them, but no obvious way for us that are using things that we've done before, right? There's a whole branch of mathematics dedicated to like how you solve these polynomials. That's uses really like some powerful techniques to try to factor these things. It's way beyond the scope of what we've done, but it's an important computational question of like, how do I solve a polynomial equation? You're welcome. And it's an active area still of a lot of concern. Yes, Caroline? Sure. So 46 is similar to those other problems where we're asking to find the lowest degree polynomial in standard form with the given zeros. I'm going to assume that even though we didn't write it in the directions, that we also meant that has real coefficients. If it didn't need real coefficients, then you just turn both those into factors, multiply them out, and have imaginary coefficients, and like, who cares? But I'm going to assume that that's what we really meant there. So again, we're going to need both their conjugates. So the conjugate of 7i is negative 7i, and the conjugate of 4 minus i is 4 plus I. I'm sorry. The conjugate of 1 minus 4i is 1 plus 4i. You knew what I meant. So I have x plus 7i times x minus 7i. Then x minus 1 minus 4i times x minus 1 plus 4i. And I'm going to multiply the conjugate pieces together. So x plus 7i and x minus 7i is just a difference of two squares. Oops. So just x squared minus 7i squared. 7i squared is negative 49, so that'd be x squared plus 49. And then this one will distribute out just like we did before. So I'm going to have x squared, and then negative x, and then 1 plus 4i, and then negative x, 1 minus 4i, and then plus 1 minus 4i times 1 plus 4i. If I distribute the x's through, I have negative x and negative 4ix. Then I have negative x and positive 4ix. And then this is also a difference of two squares, this 1 minus 4i times 1 plus 4i. So it's just going to be 1 squared minus 4i squared. So the negative x and negative x combine to make negative 2x. The negative 4ix and the positive 4ix cancel each other out. And then 4i squared is negative 16. So 1 minus a negative 16 is 17. And then I just FOIL out that stuff. So x squared times x squared is x to the fourth. And then minus 2x cubed and plus 17x squared. And then 49x squared. And then minus 98x. And then I need a calculator to do 17 times 49. Because it's too early. I guess it should have been pretty doable. You could have just done 50 times 17 minus 17, but even 50 times 17 right now feels kind of daunting. So I have x to the fourth minus 2x cubed, and then add those together. That's 66 x squared minus 98x plus 430 or 833. So I think that's going to be our answer. Is that okay?
Yeah.
Okay. So again, the trick there was to make sure you multiply both conjugate parts together first. If you try to do them one at a time, it just gets pretty gross pretty quick. So I always do it that way to get everything into a, real numbered coefficient polynomial, and then things multiply a little bit more naturally for us. It would really go the same way with if you had irrational coefficients, so you're trying to make a rational coefficient polynomial. I'd still multiply the conjugate parts together and then take those answers and multiply them together. It's a little bit nicer. You're welcome. Okay, anybody else? I haven't finished updating the tests for you guys, or I would tell you we could talk about the test format. I will go and update PowerSchool with the test format later once I finish it. I'll put it on the assignment on the calendar in PowerSchool, so if you click on it, you'll see the description or whatever. Again, I'm a little bit behind from being out, or else I would normally have that for you guys, but I'll get it on there tomorrow at the latest. Okay? The last thing I have for you guys is we haven't done our homework quiz for this chapter. Again, normally we would do that sooner, but I was out and whatever. So I'm going to put this into the content library right now. Normally we have these due at the end of class, but looking at the time, I don't think that's terribly realistic. So I just set the due date on this to be basically like midnight tonight or whatever. So you can start on it now if you want, and if you don't get to it today during school, you can do it when you get home or whatever. It's not that big of a deal to me. Just don't forget. So it's on the PowerSchool calendar. And it is set to be due at 11:59 p.m. Everybody happy there? Reasonable enough? Again, the questions aren't too terribly hard. It's one question from chapter 12 and one question from chapter 2. So, or chapter 13 and chapter 2. My couple of seniors in here, if you do end up having to take the exam, my plan for the exam format is I'm just going to take like 1 to 3 exam questions from the previous exams from this semester. So they will be exact duplicates of questions from the previous exams. I'll take somewhere from 1 to 3 of them depending on the difficulty of those questions, and that would be your final exam. So you won't get a final exam review because it's just going to be the old tests. And again, for the chapter 12 and 13 one that we're doing this week, if you come back and see me on Monday or whatever, I should have it. I'll put you guys at the top of the stack so I can give you those if you want, if you need them. If you don't end up having to take an exam, and you're like, I just don't care, that's fine. I get it. Okay. Again, does that seem reasonable to you guys? I know you have possibly a lot of stuff going on at the end of the year, so I didn't want to make the exam really complicated. Okay. Not that I think that everybody has to take it, but I haven't even looked at where your grades are or anything, so. Ben, what's up?
What's the difference between R and R squared?
So the R is the correlation coefficient. That really applies to linear stuff. And then the R squared was called the coefficient of variation, I think, or something like that. Where is it? Maybe I don't have those sheets right here in front of me. And it has to do with the fit for nonlinear things. Oh, it's the, where is it? It's the coefficient of determination. That's the name of it. But it basically, it's similar to the correlation coefficient. We're just describing how good the fit is. But it's not calculated really, except in linear situations anyway, really the same as R. It's not like if I take the square root of R squared, that's the value for R. Only in linear situations is that true. For nonlinear things, you can't do it. Is that okay? Like, yeah, or like a power function or an exponential function, an exponential reg or whatever. Yeah. Yeah, no problem. Ooh. How's this Irish week going for you guys? Pretty exciting, huh? Yeah.
Why they shorten the games?
I don't know. I'm not involved in any of those kind of decision makings. And I don't think any of the teachers really were asked, hey, why do we shorten the games?
Yeah.
I think probably for weather situations like yesterday, where it's in case the weather's really terrible, we can probably stand to be out here for an hour and a half. But if yesterday we were asking you to be out there for 3 hours or something, that might have been a little bit rough for people that weren't doing anything.
Yeah.
Because I was freezing.
Yeah.
Today is supposed to be warmer, yes, I agree.
to my calculator.
Okay.
So I like switch modes, but like whenever I go to like, can you use 4 or 8?
Yeah, it doesn't matter.
But like it's not like showing R. I don't know.
Okay, so the way to get that to come back, or the easiest way to get it to come back, is we're going to go to the catalog. So second, catalog. And the command we're looking for is called diagnostic on.
Okay.
So I'm going to skip to the D's, because everything in here is just alphabetical. So I'm looking for diagnostic on. I'll press enter. And now, if I rerun that regression, you get the R's. And you shouldn't have to do that again unless you have your calculator reset.
Okay.
But the default is not to have those on.
Okay.
So if you need to ever turn them back on again, that's how you do
Thank
it.
you so much.
Of course.
Yeah, that's what it is. Yeah, I already.
Anna, that's a pretty cool tracksuit you found.
Thank you.
You're welcome. It's very colorful.
Yeah. I thought it was
Mm-hmm. How are the spring sports going for people's? Is it weird?
It's pretty good.
It's pretty good. Do you have to wear a mask outside when you're playing?
Yeah. For tennis, we don't wear a mask.
I don't know.
Because you're far enough away?
Yeah, and there's like 2 people on each side of the court, so when you're outside,
Yeah,
you're far away.
I see. What do you think the worst sport to be having to wear a mask for would be?
Soccer track. Yeah, probably soccer. No, the track, they take it off.
My son-in-law.
Yeah.
I have to imagine like a hot 5K would be pretty terrible having to wear a mask.
Yeah, for a second, I said that we had to wear a mask while running, and then like the next day they're like, no, just kidding.
Not that it's like that big, like it's not that big of a deal, but it certainly can't be very comfortable.
Yeah.
I mean, like Galen Rupp ran like a 27:50 10K with a mask, which is like, you know, like that's real fast. You can run fast with a mask on, but yes, I imagine it's not real comfortable. And if you're already in a lot of discomfort, it's not making life easier. You guys can go to your next thingy-majiggers. You're welcome. Good luck today in your competitions. Remember, it's supposed to be fun.
Except for Jesse.
See ya, Jesse. Don't take it too seriously. Hey, David. How are you? See, you're back from your quarantine.
Yeah.
I just sent you my chapter 8 and 9 homework,
Okay.
and I attached what I was also gonna work on the email.
Okay.
And there was one thing I didn't attach. I just noticed that homework check quiz 1, I got 0 on it, so I just never turned it in.
Okay.
Is there a way that I could turn that one in? 'Cause that's
Yes. Will you send me an email and let me to remind me, so I'll make something up and just for
Okay.
you to do, and you can just email it back to me
Okay.
when you get a chance to do it.
Thank you so much.
Sure.
I'll do it like very.
Yeah.
And everything.
Yeah, no big deal. I get it. It's one of those things, like, if you tell me now in person, that's great, but I'm gonna forget.
I meant to put on the email, but I just.
It's totally okay. It's totally okay. If it takes 2 or 3 emails to get it all, it's fine. No big deal.
Mr. Cool.
Yes,
I
sir.
don't know if you're allowed to tell me this, but it's the like part of the homework quiz. But can you tell me if I set it up right, or if that should be like right here? Should that be a negative screwed into?
So the directions matter.
Standard form. Oh, so should I make it a?
So do you need the conjugate for the radicals or not?
Yes or no?
Well, if you multiplied this, these turn into factors, right?
Mhm.
And you multiply it all out, and you don't include the conjugate, are you going to have any coefficients that are non-real?
No.
Okay.
So
that,
then,
that answers your question, right?
so I should leave it out or no?
Yeah, you don't need to include it.
All right. Thank you.
I mean, if you did, like, it doesn't violate the directions, because I
Uh-huh.
don't ask for, like, the minimum degree polynomial.
Yeah. All
So,
right.
like, I wouldn't mark it wrong because the directions weren't specific enough to say that, like, oh, you did too much.
Yeah. All
But-
right. Thank you.
You know what I mean?
Yep. I'll see you Friday.
I'll be here.
Hopefully it's nice out when we go out.
Yeah, me too. I hope so.